Oh my goodness, what is this? Well, it's that Harrier CBHQ base station that has been fabloned. It says Harrier CBHQ. It's also got some terminals on the back. Obviously somebody wanted the access to the internal power supply. Why would you want to do that? To run your Echo box, they have to have voltage. So it looks nice from the front, apart from it's had a hole drilled just there. A hole that hasn't gone all the fancy my glasses. A hole that hasn't gone all the way through. So it's not a hole, is it? Anyway, that doesn't matter. Well, it wouldn't matter to me. So it's been fabloned on top, and it's been fabloned on the sides, and the back screw's missing, and the wrong screw's in the front, because it should be a black screw without a built-in washer. But more worrying is, how do we get to these screws? Oh, these are funny, aren't they? So we have to take off those furniture-y things. They're actually the right screws underneath. I could do with 4 of those. But you know what? If you didn't know that this is supposed to be black and rosewood sides, to be honest, it doesn't matter, does it? I expect it's got scratched top, and I expect it's got those rosewood cheeks all scratched, and that's what they've done. When we put this back together, I'll leave those caps off, and the customer can glue them back on. Oh, that one doesn't want to come off. They've glued that one better than the others. I didn't just lose that, did I? No. I heard something trickle down off the shelf. So what greets us inside? Let's hope there's nothing nasty inside it. No, it doesn't look like there is anything nasty inside it. All the nastiness is on the outside. It smells of smoke. It's a nicotine radio. We're going to change these capacitors as we always do. The capacitor there is tired. It's popping its top out. That one's also tired. I wonder if this power supply's set too high. So that looks to be the power output from the power supply. So I mean, this the customers, that can stay. It doesn't matter to me. If it was my own set, it could stay as well. I wouldn't be using it, but it could still stay. So we'll change those 2 capacitors. We'll change that capacitor, but you know what? I think we will test the output before we change anything. I think, with it being a customer set. Now I take 1,000,000 screws out of the bottom. You notice that one's missing. That one was the wrong size. Well, it's got a grommet in the bottom. What on earth's that for? And I don't remember them having this stand. What's that? Where's that come from? Did they have a stand? I don't remember. I'm going to have to look at my own one, aren't I? No, it can't be original, because it wouldn't be using those type of screws, would it? Oh my goodness, what's happened here? That looks naughty. Why would you want to trim the frequency? And why would you want to trim the frequency from a channel 9 switch? Oh, here we go. It's got the illegal 40 extra channel modification. Oh, it really does go through me, this. Oh dear. Oh, no wonder they sold it. Well, we're going to test it. I looked at the advert on eBay, which he bought this from. There was no mention of this. There was actually no mention. The mic was off camera, and the mic it's come with is one of those dreadful power microphones. Comes with a Power Plus battery as well from Wilco, I think. So we'll test it. We will do it with an ordinary mic, and then we'll send it back, of course, with the dreadful power mic. These are the kind of power mics that were £6.95 when the ordinary mics are £14.50. That doesn't take much adding up, does it, to how awful they are. Right, well, we'll connect the test equipment. See, I didn't see that modification immediately because until the bottom was off. So we're into the test gear now. Switch it on. It's powered up on channel 21. The meter bulb's out. It's probably the fags that's put it out. So we'll just borrow this. No, we'll use our test microphone. Don't know where that one's been. I mean, it even sounds awful. Tone switch doesn't work. Has that been turned into something else as well? Hope not. So let's see what power it's doing on transmit. Oh, it isn't. Well, there's a surprise, isn't it? No transmit either on silliness, or I presume it's been done so as on in that position it's normal. Yeah. So it doesn't transmit. Does it transmit 2 inches to our hand portable? Testing 1 2, testing 1 2. Testing 1 2. No, it doesn't. Does it receive at all? So we've got the signal generator on channel 20, 27, 79125, and we've got that at full belt, and it's not receiving in either of its silly positions. I don't expect for a minute that the VCO is locked, but I could be wrong. So resistor 4, far side. And to be honest, I'd expect that to do something. Put it in the other position. There you go. So let's see what the power supply is doing. It's doing 13.5. So now we know that this thing's been messed about with something chronic. We won't do the power supply yet, in case the radio can't be got working. So my best course of action is to try and make this actually work. It's also had a crystal filter fitted. Now, you just don't know. I mean, I don't, because we're not involved with doing things like this. 10M08A. It's supposed to be 10.695, isn't it? It's not 10.7, but you never know whether they've changed any of the way it is terminated, because the impedance is different. So if we get it working, we'll see whether it has acceptable receive performance with that in, and if it doesn't, well, we'll have to shove an original ceramic one in. So not a good start. I really am so inundated with jobs, and I can't put the time in. You know, we're going to be going down to 1 CB repair a week because I have 3 organ restorations to do. You know, so 2 are quite small, but we've got our own one, which is looking at 19,000 hours of work. So that's a lot of time, isn't it? So we could do it straightforward jobs, and this customer had absolutely no idea that this is a bag of worms. So I'll get the soldering iron on. It's 10 to 9, I'm going to finish at 9 o'clock, and we'll get the first 10 minutes of ripping some of this junk out. So 12 days later, after doing those handhelds and other things, we're back onto this base station. I've had to go to the trouble of opening up one of my own base stations to see whether I could detect a part that had been changed that I couldn't spot. And I did. There's a capacitor there which should be 82 picofarads, and I don't know what it was because it broke taking it out, but it wasn't the original one. And I've now been able to quickly set the VCO, which we'll now start on. So VCO, as ever, got to get the book out because I've got a memory like a sieve. Can't even find the right page. There it is. Channel 40. There we go. So it's 4 volts. So resistor 4, we want 4 volts. And then on transmit, we want 4 volts. So 3.99, 4.03, 3.99, 4.63. Now what I have noticed, we'll just check this on channel 1. Needs to be between 2.2, I think it is, and 1.8 and 2.5. So on receive, that's 2.17, so that's fine. On transmit, 2.2. So they're spot on. And of course that's been the snag, getting that back right and working. So I'm pleased with myself because this was so bad that I thought I might be sending this back not done, which would be such a shame. Those controls are all noisy. I don't know if there's anything we can do with that. I worry about the capacitors in a moment because the transmitter's not working. So I'm going to change that capacitor now because that could affect it. In fact, I'll tell you what, I'll change that one and I'll change that one because I may have to order that. So I'm going to once again pause the video, but this time it won't be for 12 days. Okay, so I've changed the power supply smaller one because it was getting warm, and I've upped it to 50 volts from 25, and then we've changed the 220 microfarad one there, and what have we put in? It was what that I took out 60. I think I've put 25 in, but the temperatures are up to 105 degrees for what that's worth, because that's all we stock. So let's just have a look at what's come out. So the 220 microfarad, which is starting to have its heat shrink sleeving recede, it's got discoloration underneath. Should be 220 microfarads. I mean, that reads fair enough, but it's on its way out. And for what, the 16 pence or whatever they cost, just do it. That transformer's slipperier than I'm expecting. And this one looks really poorly, the one that's come out of the power supply, but there's no sign of leaking out of this one. So let's see how near to 100 microfarads it is. Oh, see, again, it's still working, but it's on its way out. So that's 2 ones changed. We will do that before we tune the transmitter, but we've got to get the transmitter to work first. So, are we on picture in picture? No. Now we are. So, if I key up, we've got nothing. So if I put the signal generator on we can hear that coming through, so I'll turn that down. So I'll get my handy handheld. So we'll put that on channel 20, which is where we are. And to prove it's transmitting internally, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So it is transmitting, but it's not coming out. So for a start, I know we've got the wrong transistor in there. So whether or not they've, you know what they've, it's obvious what they've done. They've tried to get 1,000,000 watts out of the set, and you know, you can sometimes stretch them to 5, but we always set them to the legal limit of 4. And the thing is, it makes the difference is so tiny. You don't get 25% more range if you have 5 watts instead of 4. You probably get 20 yards more range. You've got to, is it square the power to double the range or something like that? So, I think the sensible thing to do, because we know that that transistor's wrong, is to take that one out. So I'll pause the video and we'll take that transistor out. Okay, so what I've done, I've checked the 2SC1909 and it seems to work all right according to our meter. So I've put that back in, which is a bit of a faff, taking it in and out. And then the transistor, they put something totally wrong in there, and I think it was put it in the wrong way around as well. So I put a second-hand 2SC2314 out of a scrap Maxcom or Midland or something, which we've got a chassis. Well, I bought it as a bare board for £3, you know, so and snapped in half. So hopefully we'll have some more joy, but we live and learn. No, dead. So we're going to have to go through some fault finding, aren't we? go back to the monitor receiver before I start with the diode probe. Check we're on high power. It's quite possible for that wrong transistor to have shorted out the preceding one, so you know, I'm not that surprised if there is a problem. So here's a little try. Oops, I've just dropped my radio. So I've put that a bit further away from the work so that it's hissier. We'll tune up for less noise. No, I can't see anything happening on there. Time to get the circuit out. So looking at the Rotel 240, the right way up. How am I doing? I'll take picture in picture off. So we are, that's the output, that's the driver. So the pre-driver is here. So it is transistor 4. Better look at the layout. T4, Q4. So it's the transistor just there. So emitter is shown as my right. So it's time to get the Russian diode probe out, or whatever it's called. Now these things have very short leads, as is necessary at VHF, but it's inconvenient at HF. I think we have to go on the other side of the board. Not something I wanted to do, but there we are. So we'll try and find where we think it's going to be. It looks to me like the 3 connections there. So you can see there's a slight, you probably see the slight deflection. Just move, you don't need to see the whole meter. There's a slight deflection there. Whoa! There's a massive deflection there. Just put that up to maximum and find where I was. So that was there. So the fact we've got a lot and hardly moving, I think we've got a duff transistor there. So the wrong driver transistor has put a spanner in the works of the pre-driver. So I'll put that back for now. Switch the radio off, and we'll unsolder that. You know, all these eBay loft finds, has it struck anybody why they're in the loft? They're in the loft because they don't work. It's like barn find cars. They were put in the barn because there was so much wrong with it they couldn't get an MOT. other countries' Ministry of Transport test the annual safety test on a car, which is quite complex. Let's pull that out. Let's try and pull that out. There we go. So we'll look at which way round that is, and it is the same way round as the legend on the board. So hopefully this is showing us no good. No, its reading is working. Interesting. So let's see what it should be. Q4. C2724. Pause the video. Right, we'd all be pleased to know we are getting somewhere. I've changed the transistor for one off a scrap chassis, and again, a bit like that Midland, we've got a board with very little on it, but that transistor was on it. The gain on the transistor was 150. The gain on the one I took out here, although it's working, is 100. And now look, we're transmitting. So we can look if we put picture in picture back on. We are now transmitting, and that's 2.3 watts. Looks a bit crummy, so don't know whether we've got a dry joint as well. Anyway, let's go through the tuning and just see what we can do. I am still aware that we haven't changed that capacitor. Yeah, something's a bit flaky, isn't it? So maximum. I think we've got a dry joint as well. Yeah, there's a dry joint somewhere as well, so see whether we can find that. We'll use Mr. Chippy's toothbrush. At least it's doing 3 watts now, which is better. Anyway, I'll go through this for dry joints. I think we'll clean it up with isopropyl alcohol first, and then I'll switch it off. We'll come back to, I'll have something for tea, and by that time it will have dried, hopefully. There's quite a lot to clean on this board because of the problem it's had with these fingers turning into something it's not supposed to be. So I'll get some of that on in more than one area. Getting some of the nicotine off as well. If it'd been my set, I'd have taken the speaker out, taken the meter out, put the whole radio in the dishwasher, but you know what I'm like. But I can't do it when it's the customers. I would think one of the bigger coils, the air-spaced coils rather than the enclosed ones, I would think one of those has got a dirty connection. That would be the kind of thing to expect. Anyway, I'll look at that carefully under a powerful magnifier. We may go on to the other workshop where there's a microscope. Right, pause it. Right, I've done the dry joint hopefully, and see whether it's stable now. It is now doing more than 3 watts, as you can see. So we'll change scales, go over to the 30 watt scale. So now we're at 3.1 watts. So go through the alignment. Peak, peak, peak. You know what? I need to just check this power supply. I can always come back and reset the transmitter. Let's see what we've got. So I want it to be 13.8. See what it drops to on transmit. Not bad actually, not bad. Alright, so now we've done that, we're at about 3.2 watts. So on peak. On there. That brings us to 4 watts. And that brings us to about 4.6. Check this is maximum. As it's heating up, it's going down. Oh, it's gone. Good grief, I don't like it up there. 6 point something. Gonna have to be quick. Smell it getting hot, which is not what we want. So with the service manual, because I can never remember the thing. So it's L4 to 4.4 watts, clockwise to 4.4 watts. Which is there, and then L9 anti-clockwise for 4 watts. So now we just check that it's somewhere near on the other channel. So channel 1, 4.05 watts, channel 40, 4.05 watts, channel 20, 4 watts. Spot on. Well, that works well with the right transistors in, doesn't it? So the meter on the front panel needs to read something like reality. If we can see the meter for no backlight. It's about spot on, to be honest. Don't know if you can see that, but it's about where it should be. It's that adjustment if we'd have needed to do it. Right, low power. So switch the radio to low power. It should be 0.4 of a watt. I've got nothing. And there we have 400 milliwatts. back to normal power. Deviation. Wallow. 1 to wallow. This is some dodgy looking power mic. Might really have to check this with a, shall I say, a proper mic. I'll go and get one from stock, but it's no good setting it up on that. Wallow, 1, 2. It's about the same, to be honest. So it's not far out. So I want the mic gainy one to the centre position. So after all the things that have been wrong with this is actually right. Wallow. I'll just get the little thingy out. Wallow. That's it. 2.2 to 2.5. That's where we want it. Now, frequency. Let's move the camera over to the thingy meter. Oh, well, that's not channel. That's not channel 420, is it? See if it'll go. That's absolutely miles out. Just check channel 1. Nope. Channel 40. Yeah, so they're all out the same amount, so there's nothing wrong with the way it's selecting the channels. But it's well out of tolerance. So I wonder if some numpty's changed done something with the reference crystal. Have a look at that circuit again. So looking at the crystal, we should have capacitor 1 56 picofarads. Wherever the drawing is. Capacitor 1 56 picofarads. So capacitor 1 is there. It's 56 picofarads. So I wonder if the reference crystal's faulty. Right, so having changed the reference crystal, it's going to be warm. It's come out of a scrap Maxcom chassis. Better switch the radio on. That's better. So that's right for now, but I will check it later when that's cooled down from the soldering. So that was a surprise, wasn't it? I'll just check it on channel 40. channel 99125, channel 1 60125. Yeah. No reason to expect any of the other ones to be out. So there we are, we're done with the transmit. So let's see what the receiver's doing. Better plug it into the test equipment. So we're just plugging in the synod meter. Check the signal generators on frequency. No, it's not. It is now 10 microvolts, 3 microvolts, 1 microvolt. Synod meter on, oscilloscope on. Right, we'll put an S9 equivalent signal on. We'll switch over to the oscilloscope. We'll turn the bench light off. To be honest, it sounds really good. The only thing which has been, what I'm hoping to find is the RS yellow tool. Just this one here. Turn down the volume without, rather than turning down the oscilloscope. Just check we've got maximum recovered audio. Yeah, that was absolutely spot on. Now we'll go over to the synod meter. Put the bench light back on. See if there's anything more we can get out of it. You have the extra receive part circuit on this set. Well, I'll tell you what, we have improved that already. You can actually turn down the attenuator. No, there's no alteration there. That was spot on as well. So far in, that one was out. Put a bit more signal on with this one. Remember, this has got a crystal filter fitted, which you never know whether they've messed up that. But it seems like it's working alright. I'll tell you what, we've just got a bit more quality out of it there as well. Good. So what we're getting? We're getting 0.38. No, we're not. We're getting nothing like. We're getting 0.3 microvolts. And we can hear it down to less than 0.1 of a microvolt. Right, so now we'll go back to S9 and we'll put see if the S meter's reading right. It's a bit generous. So for 100 microvolts we want that to be S9. And there we are. And then the squelch, turn it to full squelch, see when it comes in. It's a bit too tight, that it's 3 millivolts. So we'll turn the squelch down a fraction and turn it back up a fraction. That's now 100 microvolts. It's exactly where I want it. So we'll look at it at the sensitive end. We'll turn the signal generator to standby, park it at 0.3 of a microvolt, turn down the squelch. See
see where that is. So it's coming in at 0.75 of microvolts. No, it's changed. Start that again. Trouble is the squelch control's noisy. It's been nicotined, hasn't it? Try again. I'll try and clean it, but let's see where we are now. So we're coming in now. I was going to say it's coming in about 0.5 of a microvolt and going about 0. But it's so dirty I can't. No, I can't read that. No, we'll have to abandon that test. I'm sure it's right anyway, once we've tried to clean the control. So it leaves us with the high-low power switch, which is a bit dodgy, and the channel 9 switch, which isn't wired at all. So, to help with the fault finding, we had my own Harrier CBHQ out of the van, which is very inconvenient, but I'm wanting this to be half decent for the customer, and we've got to kind of see where the wiring has gone between the two sets. So looking at the top board, we should have that white wire with a red tracer. So that's not there. So we've got to look for the white wire with the red tracer. Yeah, who knows? You know what? Not that I've asked the customer if he wants that restoring, but he probably does. Just seeing if we've got any lamps, because it could really do with that meter lamp being changed. Okay, so I've gone to the trouble of copying the wiring across from my own set, having taken that apart, and hopefully we've got channel 9 now showing us channel 9. So let's see whether it transmits on the channel 9 frequency. Helps if we plug the aerial in, doesn't it? By that I mean to the test equipment. Yes, 68125, that's fine. And then back to, hopefully, flick of a switch, 79125. So I'm glad I've been able to do that for the customer. Does the RX light? It does. Does the TX light? It does. So we've just got that meter bolt and that capacitor to do, and then that should wrap the job up. Of course, I'll have to put my set together, and that's really annoying. Now, these people, they should be sentenced to reverse their illegal modification for free. Right, well, that's everything done. Let's take picture in picture off. And apart from the capacitor, I've had to order one. So hopefully that'll come tomorrow if DHL can remember where I live. So we'll take the test equipment off. In fact, we'll turn the test equipment off. And we'll turn the soldering iron off. And we'll put it on the aerial. Yeah, that would work amongst the nicotine. Right, low power, that's high power, that's low power, that's high power. 19er, Roger. somebody off frequency as usual. I did put some switch cleaner on the controls, so that squelch should now be working properly. Well, what more can I say? As usual, there's nobody on within the kind of 30 miles that you'd expect them to be on, and we'll do an on-the-air test with it in bits like this. Well, that's a real clever bloke. He can burp down a microphone with a bit of an echo. How wonderful. Off frequency as well. So we know he's using an illegal radio. Right, I better put mine back together and we'll call it a day with that. So 80 channel modification, which of course is illegal, had turned the set into a non-worker. The driver transistor being replaced by an output transistor put in backwards. We've changed those two capacitors. That one will follow. They needed changing. Perhaps that doesn't, but it's going to get it for the £1.59 they cost. Crystal filter appears to be working. I have no experience with why they do that. Oh, I know why they did it, because they thought it might get rid of some of the bleed over, and perhaps it did. I don't know. So they changed one or two capacitors in the VCO department, and they'd removed two of them altogether to add some extra bit of circuitry. So this might be one of those which nearly worked on both channels, near enough on frequency. Then we discovered the reference crystal was off frequency by half a channel, so quite an extensive repair. And of course we've changed the phase lock loop chip, and they're $14.95 to me, so we'll see. Right, thanks for watching the